For our next type of radical equation, we're going to deal with the ones where we have a radical and another radical. So where we have a radical on each side of the equation. First thing, you have to make sure each one is isolated, which in this case they are, so we don't have to do anything there. As long as you have the radical by itself, which we do, then you can go to the next step, which is to get rid of those radicals. Now you do have to check and make sure that the radical on the left side and the radical on the right side have the same number here. So this is a cube root, this is a cube root. If this were a cube root and this was a square root, it would not work. So we have a 3 and a 3, we're fine. So we're going to do the same thing to both sides of the equation. We're going to raise both sides to the cube root, or to the cube. So that gets rid of the cube root, and we get a much simpler equation. 2x minus 2 equals 22 minus 2x. We'll come back to that in a second. Let's look at the other one. Example 4, same deal. We've got a fifth root and a fifth root. They match, so we're fine to proceed and go ahead and raise these to the fifth power, which cancels out our roots, and we have 3x minus 1 equals 11 minus x. Okay, now these are both linear equations. They don't have anything we have to distribute or anything like that. They don't have any exponents. It's all good. But we do have x's on both sides of the equation and numbers on both sides of the equation. So our aim here is to get all our x's to one side. I'm going to just move everything to the x's to the left side, and I'm going to move constant numbers like this to the right side. So for this one, I've got a negative 2x over here on this side. I need to get rid of that by adding an x. That will cancel that. But in order to do that, I have to add a 2x over here. So it's going to give me 4x minus 2 equals 22. And then I can add this 2 to move it to the other side. So I have 4x equals 24. All right. Similarly on this side, I can add this x. Now this is a 1x. If there's no number, that's a 1. So I'm going to add 1x here. That gives me 4x minus 1 equals 11. And then I'm going to add the 1 to both sides. So I get 4x equals 12. So you notice in both cases I have something times x equals a number. Since it's something times x, the logical next step is to divide by that number. In this case, in both cases, it's 4. It might be a 3x or a 5x or whatever, and you would divide by that number. So we're going to divide both sides by 4. This gives me 24 divided by 4 is 6. Notice I'm not boxing that up yet because I still have to check it. Over here, dividing by 4, 12 divided by 4 gives me x equals 3. All right, so I just have to check my answer. Again, I'm going to be plugging into the original equation. So I have cube root of 2 times my x minus 2. That's my left side. And then on the right side, I have cube root of 22 minus 2 times my x. I just need to put my x value, which is 6, in there. All right, on the left side, 2 times 6 is 12. So that's 12 minus 2 is 10. So I have cube root of 10. On the right side, I have 22 minus 2 times 6. 2 times 6 is 12. 22 minus 12 gives me 10. So again, I have cube root of 10. Now I could plug that into the calculator using math option 4, but do I really need to? If I plug in once for the left side, and then I plug in the exact same thing for the right side, of course I'm going to get the same decimal answer. So I can just look at this and say, yep, this is exactly the same as this. I've written down exactly the same thing. So that is true. I don't need to do the calculator on that. I can just look at the roots and they are identical at this point, so it's good. So I'm going to keep my answer x equals 6. Coming over here to number 4, just to finish up and checking it, I'm going to be plugging in x equals 3 into my original equation. So I have fifth root of 3 times my x minus 1 equals fifth root of 11 minus my x. And I'm going to put 3 in there because that's what I got. All right, so 3 times 3 is 9. 9 minus 1 is 8. This is fifth root of 8. Again, I could put that into the calculator and get a decimal, but I don't really need to, because if I get this exact same thing written on the right-hand side, then I'm good. All right, so over here, and I'm going to have fifth root of something. Now I just have 11 minus 3. 11 minus 3 is 8. Are these the same thing? Yes, of course they are. And so I can go back and box up my answer.